as we have discussed that some of the important chemical shifts in proton NMR spectroscopy. Using this, we can solve the problems related to the chemical shift values. And we can have some problems in proton NMR spectroscopy using chemical shifts. In this problem, we have consider the following statements for 18 aniline. A. It's aromatic. B. The inner protons resonate at delta 9.28 in its proton NMR spectrum. C. There are 6 protons in the shielded zone. For this question statement, we have option given as A, ABC, B, A and B only, C, B and C only, D, A and C only. As we know that in 18 aniline, 18 carbon will be connected in a cyclic fashion with a conjugated double bond in it. If we consider this figure over here, the 18 anilines look like this, where 18 carbons will be connected in a cyclic fashion with a conjugated double bond in it. So due to that conjugated double bond, this 18 aniline will be in the form of planar molecule. So this molecule is cyclic and planar. If we consider the double bond here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 double bonds are there which contributes to 18 pi electrons. That follows the 4n plus 2 pi electron Huckel's rule, which results this 18 aniline to be aromatic. Now, to consider the magnetic property of the aromatic compounds, we can again look back to the benzene molecule. As we know that benzene is a aromatic molecule. For that, we have already discussed about the magnetic property. When we apply the external magnetic field, we'll get the external proton, that is proton located at the exterior side of the ring. They will be at the paramagnetic region. So the effective magnetic field by this proton will be the overlapping of the induced magnetic field and the applied magnetic field. That will result to the high magnetic field, high effective magnetic field to this proton over here, and it will resonate at high frequency, which will result to the higher chemical shift. And the value of this proton will be having a high chemical shift. It is due to the paramagnetic region around this exterior side of this benzene ring. Now, if we consider this region at the center of this benzene ring, it is diamagnetic region. So, if we generalize the idea that in aromatic ring, we will have a proton which is located at the exterior side, that will be at the paramagnetic region, and it will resonate at the high chemical shift, and the protons that will be located at the center, it will be having a dimagnetic region which will resonate at the low chemical shift value. Similarly, if we consider this anilines, 18 aniline structure using proton, it looks like this. All the 18 carbon here, they will be at the proton. So some protons which are facing outward to this ring, they can be shown as like this. So the proton at the exterior of this ring will be at the paramagnetic zone and it will be highly deshielded. So this, if it is highly deshielded, then these protons here, they will have a high chemical shift value at the exterior of the 18 aniline, and for the interior protons, they will be at the diamagnetic zone and it will be highly shielded. So the chemical shift for this interior proton, they will have a low chemical shift value. So considering this, now we will again look back to the statements given in the question. The inner protons resonate at a delta 9.28 ppm. So delta 9.28 ppm, it is the high value of chemical shift which is not possible for the inner protons of this 18 aniline. As we have considered in the figure that 18 aniline having inner proton, they are in the dimagnetic region and it is highly shielded. So if it is highly shielded, then they will have a low chemical shift value which is not possible as delta is equals to 9.28. So this option B cannot be the answer. And we have discussed that it is aromatic, so this option A is correct answer. Now if you consider the option C, there are 6 protons in the shielded zone. So 6 protons in the shielded zone. If we consider the figure, we have 1, 2, 3, 4, 5, 6. So 6 protons in the shielded zone. Therefore, this aniline statement given in the question will be treated as correct answer for A and C, that is given in option number D. With this problem, we will consider the general idea about the aromatic and the anti-aromatic protons. That is, like here in this figure, we have, this is our aromatic ring, in which the protons located at the exterior of the aromatic ring, they will be at the paramagnetic zone and they will be highly deshielded. So if they are highly deshielded, then the protons will be having a high chemical shift. And if proton lies at the interior of the aromatic ring, then they will be having a diamagnetic zone inside the interior of the ring and they will be highly shielded. So if they are highly shielded, then they will be having a low chemical shift for this aromatic ring. And for the anti-aromatic ring, if this is diamagnetic inside the aromatic ring, then for the anti-aromatic ring, inside the ring it will be paramagnetic zone and it will be deshielding, and outside the ring that will be diamagnetic and shielding. So this diamagnetic and shielding, that means the outside proton of the anti-aromatic ring, they will be having a low chemical shift. Using this concept of aromatic and anti-aromatic proton, we will proceed further for the more problems. Here we can see the problems below. In this problem we have the correct match for the proton NMR chemical shift delta for the following. We have given 3 figure 1, 2 and 3, and with this we need to match the correct option which is having the chemical shift for this figure's proton. So if we see carefully, then this figure number 2 is the benzene ring. So for benzene ring, we know that the chemical shift lies between the 6.5 to 8.5, and if we observe the options carefully, then in option number D, for 2 it is given 9.2, which is not possible for benzene ring proton, and for option number C it is 5.4, that is also not possible. So option number D and option number C we cancelled out. We narrowed down to B and A. Now for B we have 7.2, it may be the possible answer which lies between the 6.5 to 8.5, and for option A also it is 7.2, which lies between the 6.5 to 8.5. Now if we consider this is positively charged ring and this is negatively charged ring, for this positively charged ring, the proton over here will be highly deshielded. So if it is highly deshielded, then this will be having a high chemical shift. If we see, then here in the figure number 1, it is negatively charged, the proton over here will get shielded much more than this proton. So this will be having a low chemical shift compared to figure number 3. So now consider the option number A and B. For option number A, it is having 5.4 and 3 having 9.2. So this is 3 is having chemical shift higher than that of the 1. So option A may be the possible answer, but let us see option number B. It is 9.2 for figure number 1 and 5.4 for figure number 3, which is not possible, as we have already discussed about that figure number 3 will have a high chemical shift than that of the 1. So option A will be the correct answer. Considering the problems related to the chemical shift, we can consider one more problem here. We can see question number 100. Here the correct match of protons in column A with the proton NMR chemical shift in column B for the product of the following reaction is. Here we have given one reaction that results to this product, and we need to match the column using this product. products chemical shift for proton. Here column A, HA, that is HA here, HB here. So if we see this ring here, this is aromatic, kind of aromatic ring over here. So if it is aromatic, then straight above to this it will be at the diamagnetic region. So this will be highly shielded. So if this is shielded, then the protons over here, they will be having a very low chemical shift. So for that B, we will have a very low chemical shift compared to all. Here it is minus 0.3. So this may be the possible answer. Compared to this, others are very high value, which is not the possible answer for this B. Using this Q, we will have a answer that is 1. So let us find out using the option. Q is having 1 in the option number 1 and Q is having 1 in the option number 3. Continuing our observation to the options here. Now narrowing down to option number 1 and 3, we have Q1 here, R3 here. Now this R will not decide the answer. We'll move forward. We'll take S here, S2, S4. If we see here S, then it is H226. That is S226. It is aromatic proton. So that aromatic proton will have a chemical shift ranging from 6.5 to 8.5. Now here for H226, that is S option, if it is 2, then it will be 5.1, and if it is 4, then it is 8.5. This may be the possible answer. So for S, if we match it with the 8.5, then we'll have option number A, that is S4. So for this we will get here S. For this option we will get S2, that is for aromatic proton 226 we have a chemical shift value that is 5.1. It is not possible. So we'll get our correct option as 1, that is Q, that is B, will get the value 0.3, R will get the value 3, and for S will get value 4, and for P will get the value 2. With this, if you like my videos, don't forget to share it to your friends, giving thumbs up right down below. Thank you.